Hey everyone, in this video we're still talking about the properties of real numbers, but we're specifically going to be discussing what we call the distributive property today. So the commutative and associative properties that we talked about in the previous video are specific to doing one operation. And it doesn't say anything about how addition and multiplication interact with each other. That's where the distributive property comes in. So it says the following: if you have any three numbers, A, B, and C, A times the quantity B plus C is equal to A times B plus A times C. And it doesn't matter if A is on the left or the right. So number 2 is the same statement as 1, except the A is on the right-hand side. And it also works with subtraction. So A times the quantity B minus C is the same thing as AB minus AC. And again, the same statement applies if A is on the right-hand side. It's called the distributive property because you're imagining that you're taking the number A and you're multiplying it with both B and C, in a sense, distributing. And sometimes drawing these arrows can be really helpful. So now what we're going to do is just a boatload of examples, because this is a property that's really important for algebra, and it's also really easy to screw up. So we're going to do a load of examples. Hopefully you'll feel better after going through all of them. So here we have 3 times x plus 4. And the goal here for each of these expressions is just simplify using the distributive property. So to do that, I'm going to distribute my 3 and multiply it with x and multiply it with 4. So what we end up with is 3x plus 12. Next up, we have y times x plus 8. So we're distributing a variable rather than a constant. That's okay. Same deal. So in distributing y, we're going to get yx plus y times 8. And it's kind of convention to write your variables in alphabetical order. It's not necessary, but it is just a standard. And also to write your variables after your coefficients. Okay, so here we have fractions, which is enough to make anybody nervous. But the important thing to keep in your brain is that this works fundamentally the same way that the other 2 examples do. That is, you're taking 8 times the first term and 8 times the second term. So this is 8 times 3 over 8 x plus 8 times 1 over 4, which gives us 24 over 8x plus 8 over 4, which simplifies pretty nicely to 3x plus 2. Okay, so that wasn't too bad. Now we have decimals. But again, this is working the same way. So I'm taking 100 times 0.2. And remember, when we're multiplying by 100, it's like we're just moving our decimal point 2 places over to the right. So we end up with 20. And same deal with the 0.12. Adding 12p. All right, now I'm distributing a negative number So again, these are all working the same way, but now I have to be conscious of what the sign of my product is going to be. So when I take negative 11 times 4, signs are different, right? So I have to include a negative sign on that multiplication. And remember, we're subtracting 3a here. Subtraction is like you're adding negative 3a. I'll have a negative times a negative, same sign, which is going to make a positive 33a. And lastly here, if we just have a minus sign out front, we still distribute the same way. It's just we're kind of pretending that that negative in front is really a negative 1. And as before, I have an x and a negative 1. Signs are different, so this ends up being negative x. Minus 3 is like adding negative 3. Negative times negative gives me a positive. So that was a warm-up round. Here are some that are a little bit juicier, let's say. So here we're simplifying 8 minus 2 times the quantity x plus 3. So now there's other stuff. That's okay. When it comes to simplifying with the distributive property, it's going to work the same way. And this number out front is going to be distributed to both terms inside the parentheses. However, again, we have a minus sign, so we have to be conscious of what that is going to be doing to our answer. So we haven't done anything to the 8 yet, but when we distribute this minus 2, we're going to have negative 2x, because negative 2 times x, different signs, makes them negative. Negative 2 times 3, different signs, negative. And then we simplify. And the only like terms that I see are the two constants. So 8 minus 6 is 2. And we're left at the end of the day with 2 minus 2x. Next up, we have this creature here. We have 4 times x minus 2 minus quantity x plus 3. And again, we're practicing using the distributive property. We also want to practice recognizing when we have to use the distributive property. I'm subtracting the entire quantity x plus 3. As before, I want to pretend that this minus sign is really a negative 1. As before, when we distribute a number that we're subtracting, it's going to affect the sign of the products. So we have 4x minus 8, and then the negative sign distributed. So negative 1 times x, different signs, minus x. Negative 1 times 3, different signs, minus 3. And then we want to look at our like terms. So the constants are like terms, and we also have the x's being like terms. So to combine like terms, I'm essentially adding or subtracting the coefficients. There's a 1 in front of this x. 4 minus 1 is 3, so these two combine to give me 3x. The 8 and the 3 are both negative, so I add their absolute values and keep the sign. And that about wraps it up for our examples with the distributive property.